Alright, so welcome back to Galantis Academy. In today's video, we'll be discussing friction. Basically, the introduction, that is building the foundation, because in subsequent videos, all we'll be treating are just mainly questions, right? So that any question that is being brought to you or set in your external exams, you're able to tackle it without any hurdle, right? So, what's friction? When you say friction, we have to understand what friction means. So friction is simply the force that opposes the motion of a solid object over another, right? So the is simply motion that opposes motion, right? Let's assume this is a box, right, on a solid stuff here, right? So there's actually there's in the microscopic level, there are actually small particles on it, right? Therefore, any box placed on this line will not be able to move fast, will not be able to actually proceed faster, right? So it can be helpful sometimes, maybe while walking, right? Or it can also be an hindering force. I get it. As you know, this is the main reason why the efficiency of a machine can never and will never be 100, because of friction. I get it. It creates wear and tear on the machine. Alright, so let's understand friction. Friction arises from microscopic interaction between surfaces. Just like I've said in previous slide, rough surfaces have interlocking irregularities. That is, on every surface you see, right, there are just like a little bump, something like this, a little bump, right, that prevents rapid movement. I get in. Some might not be seen, some might be prominent. I get in, but friction exists on all surfaces. Rough surfaces have interlocking irregularities that resist motion, which I've said. Smooth surfaces, though they have interlocking, but they are actually less, right? They're actually less. Let's say tiles now. It's easier to fall on a tile ground than probably one that has just been cemented. I get it. Because the tiles serve as a smooth surface. It reduces friction, though friction is present, but in a lesser extent. Alright, so what are the types of friction we have? Basically, there are just 4 types of friction. In a broad category, I like dividing it into 2, which is solid friction and maybe fluid friction, right? So now the first 3 I mentioned here, I actually categorized it as solid friction, while the last one being fluid friction, just on its own category, right? So first, what's static friction, what's sliding friction, what's rolling friction, what's fluid friction? What do you understand by these terms? Kindly comment in the comment section. Now, static friction, this is the type of friction that prevents objects at rest from moving. Take note of this keyword, at rest. I get it, because we will have to see that others which involves friction, they do not actually specify that this object in question is at rest. So for static friction, this type of friction prevents objects at rest from moving, right? Like for instance, when you place a candle, right, on your decks, or probably a lamp on your decks, what is acting between that lamp and the table or the decks, right, is actually what? Static friction. Generally, it increases with the applied force, right? It increases with the applied force to a certain limit before motion can occur. Now, a good example is a grounded vehicle, right? That is a vehicle at rest, right? Try pushing it. Though it might move when it overcomes this static friction, right? That is the opposing force, right? It might move, but you have to keep on applying and to a very, very large extent, right? So the next one, which is known as sliding friction. Now, from the name, sliding, right? For the previous one, which is static. Static means something at rest, maybe, right? So I told you that the keyword there is what? at rest, exactly, right? So now for this one, sliding friction, it actually occurs, right, when a particular object moves over or slides over another object, right? So for this one, there is actually a motion in place. I get it. So it's one that occurs when an object slides over another, right? For instance, maybe a moving vehicle, for instance, right? A moving vehicle, there's actually a friction that exists between that vehicle, between the tires of that vehicle and the road, right? That's why at a particular period of time, or at an extended period of time, right, you have to change the tires of that car, right, because of wear and tear due to friction, right? So generally, it typically occurs after static friction. So when I push probably a box, let me use a box, right? When I push a box, for instance, right, at some certain point when the static friction is overcome, right, that box might keep on moving without me applying any force. Yeah, it's very possible, right? So what is playing out in that instance is actually what? Sliding friction. So it typically occurs after static friction, just like I said, right? And it's overcome and dependent on factors such as the material properties, right? The material properties and the normal force between surfaces, right? Now the normal force is like opposite and equal to the weight of that object. In the next video, I will explain that in details. But for, just like I've said in the beginning, DJD Foundation, we're talking about the basics only. Now, the next one, which is rolling friction. Simple names, simple to define, just simple, right? No stress. Now, what's rolling friction? Without being literally now, right? Okay, when I say rolling friction, what do I mean? That means friction that exists when an object is rolling. Yeah, something like that, right? So now, rolling friction opposes the rolling motion of object. Do you get it now? So rolling friction opposes the rolling motion of objects on surfaces. Do you get? Now it's usually less, right, than sliding friction due to the smaller area in contact. Okay, now let me give you a graphical representation of what I mean. Now this is a ball, right, rolling on the floor. You get just a little area is in contact with the ground, with the floor, right, meaning that the friction that will be experienced by this object will be very minimal, right, because of low smaller contact area, right, between the rolling object and the surface and surface, right, in question. So now in sliding motion, like what I discussed previously when it comes to rolling friction, right, in sliding motion, every point of the body has only translational or linear motion, right? That's every point of the body has a translational or linear motion. But in the case of rolling motion, different points have a combination of linear and rotational motion. They have a combination of linear and rotational motion. Please take note of this point as it might be asked in your exam. Alright, so the next one, which I termed as fluid friction. Now, fluid. When you hear fluid, what comes to your mind? Probably liquid, right? Now, I'm here to tell you that it's not only liquid that can be described as fluid, right? The gas is also a fluid, right? Now, so fluid friction resists the motion of objects through fluids such as air or water. Do you get? Now, what are the examples? Examples include air resistance experienced by moving vehicles such as airplanes, aircraft generally, and water resistance encountered by swimmers, submarines, boats, anything that follows the en route of liquid or water, right? Good. So now, fluid friction. That's all about fluid friction. Alright, so what are some factors affecting sliding friction? Right, because sliding friction is one that is usually being asked. You will notice that when I'm solving questions, that most questions fall under this category. So several factors influence the magnitude of sliding friction. One of them, in short, I've mentioned both of them. If you're smart, you should know by now. The first one is what? Material property, right? Material property. Different materials have different inherent friction coefficient, right? So the way maybe a block, right? A block flows on or slides across the ground is different from the way, let's say, an ice block, right, slides across that same surface, right, they'll be different. So the material properties determines affect sliding friction a lot, right? The next one is normal force. I told you that normal force is actually a force that is opposite and equal to what? To the weight of that object, right? So basically, right, or as a law, the greater the normal force, right, the greater the sliding friction. It makes sense. Since I told you it's opposite and equal to the weight, therefore when we have higher weight, this means that this object in question will most likely love to remain in the static state, right? Will most likely love to remain in what? In at rest, at a position of rest. Is that clear? All right. So application of friction. In the beginning of this video, I told you that friction, depending on how you see it, can be helpful and also can be detrimental, right? So some application of friction, as I'm considering only the good part of it, it can be used for, it's necessary for locomotion. Without it, most probably we might slip when we fall down, right? Just such as that experience when you mop your room or when you mop your house, right? For gripping objects, for holding your pen, right? For controlling movements, driving your car, writing, right? Tile design and all that are all application of friction. All right, let's have a recap of what we've treated so far. Right, so you guys prepare for the next video. Expect, right? First of all, what I say friction is, can you try? Now, friction is the force I told you that opposes motion. Just put it simple as that. Friction is the force that opposes what? Motion. I also told you that there are 4 basic types of friction. Though I categorize my own into 2. You don't have to follow my categorization. Just stick with this. There are 4 basic types of friction, right? The first one is the static friction, the sliding friction, rolling friction, and fluid friction. We talked about factors affecting sliding friction, which are basically 2: normal reaction and the material. What's the material in question, right? Application of friction is, it helps in writing, locomotion, movement, and so on and so forth. Right, I hope you enjoyed this video. I hope you learned a lot from it. Don't worry, this is just basic, this is just the beginning, and in few days time expect another video discussing in details calculation with some questions on it and all that, right? Thank you so much for watching. Thank you so much, and share, subscribe, don't go yet. Subscribe, like the video, share. Thank you so much for watching. Have a great day ahead. Bye.